We've talked about these unknown numbers before. Does anybody know what I'm going to say? Because by the time you get in the 7th and 8th grade, you could probably stand up here and do the exact same thing I am, because it's all review of what we're doing. For example, let me give you an example problem that you understand. For example, if you have an addition problem that says 6 plus b equals 15. Now I know that all of you right now know what the answer is, but I tell you that that is not what I'm looking for. You people are looking for processes and algorithms. Remember what an algorithm is? The way of doing something, because yes, you might know the answer to this, but you may not know the answer to this. That one may not be quite. You do the same process. The algorithm on doing them is the same, but you can do one in your head on the left, but the one on the right you can't. So the question would be, how do you solve such things? How do you solve any of these missing number problems? In bright big letters. Somebody help me, Maggie.
We do like 15 minus 6.
Yeah, I know that's the thing, but I want something that works with everything, even a subtraction problem. Because Maggie, I can tell you if I had this problem here, m minus 75 equals 391, I would not do the same thing as that you said. I wouldn't subtract it in this case. But not always, in every problem would I. What is the one thing that will help you solve any of these types of problems? Alex?
An algorithm?
Yeah, but what is it? That's what I was asking for. Julia?
Well, you do a smaller problem like 6 plus 4 equals 10 and figure out how the b would be in that position and how you would get to do it. So it would equal.
You hit it right on the nose there. Think of a basic problem that you know and find the correct process or algorithm or pattern or whatever you want to call it. It all means the same thing. Okay, in other words, these big numbers kind of throw you for a little bit of a loop. I think my projector's getting like dull. Okay, but if I have this addition problem and I'm missing this middle number, think of an easy addition problem, and it can be anything. 7 plus 3 is 10. If you are missing the middle number here, what do you do with those two numbers to get that middle number? If I have a 10 and a 7, what do I do to get the 3? It's not a hard thing to figure out there. Caleb?
Subtract.
Yeah, you're going to subtract, and that's the same thing you'll do in the hard problem to get your answer. You'll take 7, 5, 4, 2, subtract 375, and you'll end up with, what, 7,167. And that works for anything, whether it's addition, subtraction, multiplication, or division. Did I do that right? I was close around there. Same thing with this one. With a subtraction problem, think of an easy subtraction problem. If you get 8 minus 2 is 6, if I'm missing the top number here, what do I do with 6 and 2 to get 8? Andrew?
Yeah, then.
Right, and that's going to be the same thing I'll do in this problem. I'll take 391 and add 75 to it. 466. And it could be division too. I'll make it into this here. Here's a great one. What if I have, and I'll write it out like this, what if I have m divided by 12 equals 3? Most people, I'll let you answer for yourself, most people on this, to thine own self be true, automatically just look at that and go, well, the answer's 4. Be honest with me if you thought the answer was 4. Come on. Be honest if you thought the answer to that was 4. Okay, you're not right. Why? Because of this. If you do what I just said and think of an easy problem that you do know, let's do 6 divided by 2 is what? 3. If you know this, if I'm missing the top number here, if I was missing the 6, what do I do with the 2 and the 3 to get 6? Multiply, right? 2 times 3 is 6. So to get my answer for the letter M there, I do the same thing there. 3 times 12 is actually 36. So you have to be, and we won't do that for tomorrow, by the way. I think it's just, I thought I'd just throw that in there because you guys are well in advanced in age and years. What about this problem here? 15 plus 13 plus 9 plus q equals 100. Suggestions on that one? Before you think of an easier problem, what do you think we should have to do there? Grace?
15, 13, and 9 together.
Yeah, put together the stuff that you can first. 15 plus 13 plus 9 is what, 37? And then it just becomes 37 plus q equals 100. And here's where I think of an easier problem, maybe 6 plus 2 is 8. If I'm missing the middle of 6 plus 2 is 8, what do I do with 8 and 6 to get 2? Yes, subtract, thank you, whoever said that. So I take 100 and subtract 67 from it, and it is 33. You can ooh and ah at any point in the presentation. Come on.
So if you have like the one that we had just now, which is adding, you would do the opposite of adding and subtract.
In this case, yes, but that's not always true on everything. You can't always, it's not always going to be the opposite. Especially when it comes to doing a subtraction problem. Sometimes to find the answer to a subtraction problem, you actually add, which is the opposite. Sammy Bollinger.
Wouldn't it be 100 minus 37? Yeah.
I don't know. Did I do something wrong? Sure. Be a little nitpicky. Yeah, I mean, Sammy. Yeah, it should be. I don't know where that came from. 63. That's the first mistake I've made this year, believe it or not. No wonder nobody was oohing and ahhing. It was really my own fault. We did cover minuend, subtrahend, and difference, correct? Yes. Say yes.
Yes.
Other than that, children, you can't go wrong if you think of an easy problem and find the process or the algorithm.